Hello. Today, I'll be presenting a cloud-based pipeline developed to predict daily sales from Rossmann drugstores. Although cloud agnostic, this end-to-end solution utilizes Google Cloud's ecosystem to automate data acquisition, pre-processing, and machine learning deployment. Let me walk you through the steps that bring this pipeline to life. The Rossmann dataset is a backbone of this project, containing extensive historical sales data from over 1,000 stores across various locations. Each data point captures vital attributes such as daily sales, promotional activities, holiday schedules, and competitor proximities. This granular information enables us to identify key drivers of sales trends. The Rossmann dataset is the backbone of this project, containing extensive historical sales data from over 1,000 stores across various locations. Each data point captures vital attributes such as daily sales, promotional activities, holiday schedules, and competitor proximities. This granular information enables us to identify key drivers of sales trends. As we can see that this is a competition page for Rossmann store sales, in which the participants are required to prepare a forecasting model for predicting the sales using store, promotion, and competitor data. This is the data page for the competition. And here we have four files: train.csv, test.csv, store.csv, and sample submission.csv. For the purpose of demonstration, we would be discarding sample submission.csv and store.csv and would be only using train and test.csv. However, scale and complexity of the data, combined with the need for timely and accurate predictions, make it clear that a robust pipeline is essential. Traditional approaches often fail to keep up with the volume and velocity of the data, nor the demand for real-time insights. By leveraging cloud-based tools, I aim to build an automated, scalable pipeline to process, analyze, and forecast sales efficiently. This cloud-powered system ensures seamless integration of data pre-processing, model training, and deployment, enabling Rossmann to make data-driven decisions quickly and reliably. It's not just about predicting sales, but empowering the business with actionable insights delivered consistently and at scale. The journey starts with Apache Airflow, which is an open source platform that allows you to programmatically author, schedule, and monitor workflows as directed acyclic graphs. Here, it orchestrates the first stage of the pipeline. But before this, I need to create a Cloud Composer environment in Google Cloud and then open the Apache Airflow UI from that. Cloud Composer is a fully managed orchestration service on Google Cloud that simplifies workflow creation, scheduling, and monitoring by leveraging Apache Airflow. So as you can see here, I have created a Cloud Composer environment, and in which if you click on the Open Airflow UI button, you would be redirected towards Apache Airflow. And there are two DAGs already present in this Apache Airflow dashboard. The Airflow monitoring is a default DAG, and we don't need it for now. The fetch Rossman is the one that we'll be using. It is a DAG to trigger the Python script called extract and push to gcs.py. This is the Python script. It starts by calling the function download and upload to GCS. In this function, we instantiate a storage client and set up our target cloud storage bucket, which is gcloud pipelines, and then perform some system-based commands using the Kaggle API to download the competition data from the Rossmann store sales and unzip the data file. As we said, we removed the sample submission.csv and store.csv files. Then we move on to the remaining CSV files and pre-process them using the function called preprocess. After my exploratory data analysis through this data set, I found out some of the outliers that need to be removed. And this line does exactly the same. Then I return the data frame. And as soon as I have the data frame, I store it into the same CSV file and then upload that CSV file, the transformed CSV file, on the cloud storage bucket. In sum, the script performed three critical tasks: downloading the data from the Kaggle using Kaggle API, pre-processing it, and storing the data in the cloud storage bucket. This automated stage ensured that the dataset is ready for the next steps without requiring manual intervention. Now, the pipeline is designed to be event driven. A cloud function monitors the cloud storage bucket for new files. Cloud function is a serverless compute service on Google Cloud that lets you run event driven code in response to triggers from various Google Cloud services or HTTPS requests without managing the infrastructure. As soon as the pre-processed dataset is uploaded on the bucket, the cloud function is triggered, and the function is responsible for initiating the next step of the pipeline, which is the data flow job. So here you can see that I have created a cloud run function, which is being named as trigger df job. You can also create the same function by hitting on the create function button and following the subsequent steps. The source code of this function is also visible to us under the source section with the file main.py, and it actually contains the code for triggering a data flow job. And the requirements.txt is basically a file that defines the dependencies required by the main.py file. So this cloud function triggers the data flow job that moves the processed data from cloud storage to BigQuery. We use Google's CSV to BigQuery template within Dataflow to ensure seamless and efficient data transfer. BigQuery acts as our central data warehouse where the cleaned and structured data is stored, ready for analysis and machine learning workflows. So this is the schema for the BigQuery table. It has the value for store, day of week, date, sales, the customer footfall on that particular date, whether the store was open or not, whether there was any promotion given or not, uh, whether there was a holiday from state or not, and of which type, and whether there was a school holiday or not. A preview to this table shows the values present in each of the columns. And once the data is in BigQuery, we use Vertex AI training pipelines to build an AutoML machine learning model to predict store sales. Vertex AI simplifies the process of creating and fine-tuning a regression model to predict daily sales. Key benefits of using Vertex AI include automated feature selection, hyperparameter tuning, and scaling trainable environments. After training, the model would be registered to the Vertex AI model registry, and from there, it would be deployed to a serving endpoint. So as you can see that this is a Vertex AI dashboard, and if you hover over the model development section, and under that you can see the training subsection. Uh, as soon as you click it, you see a model already being trained, which is this model only, the Rossman data for the Rossman data set. You can also create or train another model by hitting on the train new model button and then selecting a data set. In order to create new data set, you need to hover over the data section and then clicking on the datasets subsection. Here you can see that I've already created one dataset. As soon as you hit on the create button, you have the option of selecting for which particular type you wanna prepare the model on, or which particular type of your data is. And then further, you can either upload the data from your local storage or select the data from BigQuery and create this dataset, and eventually create or train this model using either custom method or by using AutoML, which we did in this particular project. As soon as our model is trained, it is stored in the model registry. As we can see here, and then as you click it, you would have option to deploy the model to an endpoint by clicking on this deploy and test button. and then clicking deploy to endpoint button. It would allow us to get online predictions for our input features for a particular record, or we have also the leverage to get batch predictions on a set of input records by hitting on this create batch prediction button. This makes us come to the end of our pipeline. And thus, in conclusion, this pipeline leverages cutting edge cloud technologies to automate and scale the entire workflow from data acquisition to real time predictions. Each component, that is Airflow, Cloud Functions, Dataflow, BigQuery, and Vertex AI, work seamlessly together to provide Rossmann with accurate and timely sales forecasts. Thank you for your time and consideration, and I'm happy to answer any questions ahead.